There's a good chance you could be watching this one because you're stuck at some point. It's one of the harder proofs in this packet. If you thought a lot of these proofs are too easy, or maybe they've been getting easier and easier, maybe this will be a little bit challenging for you again. So let's look at what they give us and where we can start. Line AC. Well, it's not one of our vocab words, but if you scroll down your sheet, maybe you can find the closest to it. Maybe look for a picture similar to the one we got. Not exactly. I think we drew a picture in our notes there, or on that gold sheet. Pause the video if you want to try, or maybe you already have done that. Linear pair is what you're looking for. So find where those conditions are met, where we have a linear pair. We have a pair of angles here that form a line. That's kind of what they're hinting at with the line AC. And you won't find definition of a linear pair, I don't believe. You'll find the supplement theorem. So that's what we're going to start with, the supplement theorem. A lot of students want to say, well, that means the measures add up to 180. Well, that's true. We'll get there. That's where we're going with this. But that's not what the supplement theorem concludes. The law of attachment says make the conclusion for that true conditional statement if your conditions are met. Well, the conditions are met, and the conclusion is the angles are supplementary. So I'm going to make that about the two angles that form a linear pair. Angle 1 and 2 form a linear pair. So I'm going to make the conclusion that angle 1 and angle 2 are supplementary. Now we can say, well, or maybe you want to pause the video and try to figure it out on your own from there. But now we can say what supplementary means. Definition of supplementary angles. Maybe go look that up and see what does the conclusion say, or possibly you already know that the measure of angle 1 plus the measure of angle 2 will equal 180 degrees. Now I'm looking, somehow I have to get to them being perpendicular, but maybe that's what's going to make this one a little bit trickier. I have an equation. I also have a statement of congruency. Maybe I'm close to being able to use the replacement rule. But to use the replacement rule, I need to have equations. So I'm going to change that congruency statement and say all the measures are equal. That's what it means to be congruent. And for an angle, well, there is only one measure. So that means that one measure would be congruent. That's what that vocab word means, congruency. So definition of congruent angles. Congruency means all the measures are equal, including just that one that you could measure in an angle. What can you replace? Well, 1 and 2 are the same. So we're going to replace that into the equation. This isn't the tricky part just kind of yet. I mean, usually this is where you got to do a little thinking, figure out how it fits together, but I'll help you through this part. We're going to replace, well, it doesn't really matter which one we replace with which one, so I'll leave measure of angle 1, and I'm going to replace measure of angle 2 in that equation with measure of angle 1. That's replacement rule. Now, why would I want to do that? What do you have to show? What does it mean to be perpendicular? Well, it means it forms right angles, so you have to show that this is forming right angles. Okay, well, how do you know if something's a right angle? You have to prove to me it's 90 degrees, so that's where we're going. I'm going to show that angle 1 is 90. That way it'll be a right angle. I'll be able to say it's perpendicular. And off to the side, I'll show you kind of what's going to happen here with this angle 1 and angle 1. If we had x plus x equals 180, you could solve that no problem. You'd say, oh, 2x equals 180. Divide by 2, we'd get x equals 90. That's what we're going to do with the measure of angle 1 plus the measure of angle 1. I'm going to use some algebra here and say, well, measure of angle 1 plus the measure of angle 1 is 2 times the measure of angle 1. Combining some like terms, that's some algebra. I'm just going to say, oh, that's some algebra. Fact of algebra. Why not? And then divide both sides by 2. We actually have a more specific property than that for than just saying algebra. Maybe you want to look at some of your algebraic proof properties. I do believe it's with your geometric proof properties because we use it quite a bit. But you're looking for the property that says you can multiply or divide on both sides of the equation. That's M, P, E. Kind of getting long here. But I've showed that measure of angle 1 equals 90. So what can you tell me? If measure of angle 1 equals 90, what do you know about it? I can say angle 1 is a right angle. Why? Well, that's what a right angle is. Definition of a right angle. So there's another vocab word in there. Well, we're trying to prove they're perpendicular. What do you have to show for them to be perpendicular? Well, that it's a right angle. So I think that would be our last step. So segment AB is perpendicular to BD. How do you know? Well, because they formed a right angle, and that's what it means to be perpendicular. Definition of perpendicular lines. They would have to form a right angle, which we showed that they did by showing that measure of angle 1 equals 90 degrees. Pretty tricky. Probably the longest video for all these proofs that we've made so far. Proving them perpendicular.